Right, I've skipped out 502 because 502 is the same as 501, only you have to factorise the question first. So by doing 503 also you have to factorise the equation first. But remember, every time you solve a quadratic, the equation has to equal 0. Alright, I've shifted the 12 over to make the equation equal 0. You can't solve a quadratic unless the equation equals 0. And you'll probably try this once and say, "Sir, how do you solve this?" And I'll say, "You have to make it 0. I've said it. Okay, and I promise I'll correct someone. Okay, so we're going to factorise now. It's a standard quadratic. So x has gone in the front. Two things that multiply together to give 12 and a difference of 4. 6 and 2. Great. And they have to give minus 12 and minus 4. And minus 6 plus 2 will work. That's because, and you just should check it, multiply the outside, 2x, multiply the inside, minus 6x. So plus 2x minus 6x winds up at minus 4x. And if you multiply the last two terms, right, minus 2 times positive, minus 6 times positive 2 is minus 12. That works. And then we know that x times x is x squared. So we're confident that we've got the factorising part of it correct. And very quickly, solution 6 and what? Minus 2. Next one. Again, make the quadratic equal 0. So subtract 4 from both sides. X squared plus 8x minus 5 minus 4 minus 9. What does it equal?
0.
Thank you. Factorise. X goes in the front. Things that multiply together to give 9 are
8 and 1.
and 8 and 1 and what? No, not 8 and 1. Multiply together to give 9. 9 and 1 and 3 and 3. Now the difference has to be 8. So of course choose 9 and 1. 9, 1. 9 and 1. Think about the signs. We want a negative. I'm going to put the negative next to the 1 because plus 9 minus 1 gives plus 8. Answers: x equals what? Minus 9 and 1. Right, as I've been harping on, every time you solve a quadratic, it has to equal 0. So this one, it doesn't equal 0. Therefore, we have to put the 8 on the left-hand side, and then we have to refactorise. So I'm actually going to expand, shift the 8, and then factorise. You ready? First, outside, because this is foil, right? F-O-I-L. Outside, minus 6x. Inside, minus 4x. Last, plus 24 equals 8. Minus 6x minus 4x minus 10x. Subtract. Be happy to do 2 steps at once? I won't. Now I'm going to shift the 8, subtract 8 from both sides. X squared minus 10x, 24 minus 8. What does it equal? Yahoo. Factorizing. Things that multiply together to give 16 and a difference of 10. 8 and 2. And I think they're both going to be negative, do you agree? Right? Because minus 2 minus 8 is minus 10, and then minus 2 times minus 8 gives positive 16. Okay, solutions? Brilliant. Number 29. This is number 29. Again, at this point, you possibly wouldn't know it was a quadratic equation. The telltale sign of a quadratic equation is an x squared. You can't see any x squareds there at the moment, but when we shift it around, you'll see there are. First thing I'm going to do is I'm going to get rid of the fraction. Okay, remember Mr. Arden doesn't like fractions. I want a linear equation, so I'm going to multiply both sides by x plus 1. X minus 1. So the working is to multiply both sides by x minus 1. Do it to the left hand side. Now you actually have to put that 2x plus 1 in brackets. The other way of writing that might be this. If you're going to multiply the left hand side by x minus 1, you have to do it to both terms. Both those things say the same thing. Do you agree? X minus 1 brought over to here, multiplied by the 2x and also multiplied by the 1. I've written it like that, or you can write it like that. Again, I haven't got 0 equal to 0 yet, therefore I'm going to have to expand, shift, factorize, solve. Expand, shift the 27, factorize, and then solve. Okay, I just multiplied that and that out. And everything over here, if you multiply something by 1, how it would look, equals 27. Collect the x's, minus 2x plus 1x. Minus 2 plus 1. Subtract 27, both sides. What's minus 1 minus 27? Okay, now I'm going to have to factorize one of these horrible ones with a 2 in here. Oops. Right. Factors of 28. Okay, 1 and 28 is 1. 2, 14 is another. 7 and 4 is the other one. And again, you'll remember from manipulation that it's a trial and error game. But we're looking for a difference of 1. I think it's going to be 7 and 4. I've done a few. I've done a few of these before, and I can see that it's going to be 7 and 4. If I put the 4 here and the 7 here, notice that the 4 multiplies by the 2x to give 8x minus, say, the 7x. That's a difference of 1. I need to put a minus here and a plus here. Okay, it might take you 30 seconds longer than me, but that's fine. Or some of you might be faster than me, that's fine too. X equals 4. And what would be the other solution? 7 over 2. 3.5. You generally write things as fractions in algebra, so you'd write it as 7 over 2, not 3.5. Although 3.5's not rounded at all, so 3.5 is quite okay in this case. But where you have to round in algebra, you leave it as a fraction.